coming to Larissa's defense, and it's really an honor for me to be able to introduce her for this presentation. Larissa is, I think, a very unique and special graduate student at MIT, and she's very passionate about STEM education and education for girls, and of course that's what she'll be talking about today. And I think it's really important that this is very personally motivating for her. And in fact, what you'll be seeing today is really of her completely of her own thinking and motivation, and she's really driven her work very independently. And I think we're all going to enjoy the presentation and learn quite a few interesting things in the process. So, without any further delay, Larissa.
Thank you, David. Thank you, everyone, for coming. I'm so glad to see you all here. So, yeah, of course, you all read the abstract. Just kidding. Let's talk about diversity in engineering. Bad design. When in the 90s, hundreds of women and children were badly injured by airbags because they were just not tested on anything but what represented tall males. And that is attributed to the lack of women in engineering, which apparently influenced the policies around that. Good design. Amos's wheelchair, most of you who are here at MIT know that project, and he adapted it for developed countries as well, for the US. And what was interesting for him to find is that 9 out of 22 needs of the developed country users were identified by people in developing countries. So these are just 2 examples that if we have diversity in teams, usually the design turns out much better than if it's a very homogeneous team. So let's look at the reality. This is MIT, it's very diverse, but still most of you might be familiar with the fact that women are underrepresented in engineering. And here are statistics that kind of sample across schools, but you can kind of see girls lose interest in tech careers pretty early on, and it kind of goes downhill from middle school onwards. Peak being at 12 years old when they start thinking about what kind of woman do I want to become, and culturally tech doesn't really seem to be on the radar, in contrast to boys who are much more open to tech careers. So why is that? If you dig deeper, you find that what girls that turn away from tech don't see is relevance. They don't feel like they're needed or can make a difference. And the few girls that stay interested in engineering have a key experience, which is that of, I can make a big difference with this. If you look closely, you'll see that there's a familiar name on the slide. I was no exception when I turned away from tech after going to a technical high school that I just didn't see, why would I be an engineer and go through all the pains. Until well into college, I had a key experience where I got to program a robot which was used in the production of the factory where I was working at the time, and it improved my coworkers' jobs, they thanked me for it, and it got the respect of all the engineers. That was my key experience of, yes, engineering is actually something that you can have a big effect with. And that's when I turned my, studies around. So roughly, this presentation is structured as follows. Hi, John. First, we'll talk about what is our solution going to look like, what are our goals and objectives. Then we're going to talk about some experiments. Then we'll analyze the results from these experiments, and then discuss some work in progress. So you can quantify the importance of social impact to how girls lose interest in engineering. I found these numbers in a paper that I came across in my literature review, and what I saw, they didn't point that out in the paper, but it is striking because it shows that at the same time, girls place much higher value on social impact in careers at the same time as they don't see that engineering has a social impact as much as boys see that. And this is already for Generation Z, which is all about social impact already compared to like Generation X. So what makes social impact? Like what is it for girls that they associate with that? What is relevant to them? And I looked at different careers that girls want to pursue. Many girls want to become teachers, lawyers, doctors, and so forth. You can categorize these into altruistic, social communication related, medical, and artistic. And some works in literature already just ask, say, when they run surveys, they already ask for exactly these fields, and they roughly come to the same result. So overall, these are the areas that girls see as relevant. And I like to combine them into what I kind of like to call the relevancy space. And you can place existing outreach activities on this space. For example, I went to a STEM day at Purdue, and they had this different activities like girls building prosthetics, sticker circuits. Then there are programmable wristbands you can buy as an activity that light up, and Scratch, which is this project that came out of the Media Lab's Lifelong Kindergarten, which is dragging blocks of code around to make, say, videos or games. It's browser based, and they already have like 1.5 million users. Kids can log in and drag blocks of code around. But there are criticisms for that by many young users, such as you can basically only build games and stories, and that's kind of it. So really, with all these different activities, there's nothing in between. And what I propose is to combine all these and create a connected device for everyday and medical use that can be freely created. That is what I propose as the possible solution. So that is the what, but now we have to talk about the how. And we want to create something that is motivating, because motivation is that part of learning that can impact the mindset change, and that makes things fun, and that's what we want to do. And this projector is also fun. Okay, sorry. So yeah, one of the kind of the gold standard in intrinsic motivation research, intrinsic motivation being the part of motivation that's like, I really want to do this even if no one pays me to, is Ryan and Desi's work, and they identified these 3 factors that are relatedness, autonomy, and perceived competency. Relatedness is what we just talked about, where we're like, this is the relevancy space. Autonomy means that you have freedom to do things a certain way, you can find your own path. And perceived competency means I feel like I can actually do this. So if you guys have hobbies, chances are these boxes are kind of checked. And another interesting work is what is a flow experience, the kind of stuff that you want to keep doing and you just kind of can't stop or don't want to. And what is important for that is that both the challenge level and the perceived competency are in balance. And also continuous engagement, meaning there's always new prompts that kind of keep you going, or you feel achieved when you achieve certain tasks. And interestingly, the Media Lab researchers that invented Scratch or even sticker circuits as an activity for outreach work with a lot of the same factors in their idea of constructionism. Constructionism being the teaching that goes through letting young people create stuff of their own. And Scratch is based on that, and sticker circuits and so forth. And they don't really call them exactly by the same names, but they use all these same factors. Another thing that came out of that same lab is the idea of meaningful objects or evocative objects, meaning that if you build something of your own accord, you kind of own it. This is similar to this IKEA effect. Once you've built it yourself, it's like yours. And you're more attached to it. And that is something that I want to especially leverage with this project and create more motivation through that. Another motivator specifically for girls is collaboration. In part that it has to do with the so-called fixed mindset. Girls don't like competition as much as boys do. In tendency, they like more collaboration. I mean, these are all tendencies. Of course, it's all the spectrum. But in tendency, this is kind of what we have to design for girls specifically. And so these are the goals, the motivational goals, what we kind of want to design for. And we'll come back to that later, whether we've met these goals. From them, we can derive functional requirements for the thing we want to build. And so we want to build something that is socially meaningful, impactful, artistic, real-world, experiential, experimental, collaborative, shareable, challenge variable, physical, and so forth. Okay, so you can, yeah, I interpreted these to create these functional requirements or requirements of the solution. And the opportunity that I want to seize with this project technologically is that of Internet of Things. I mean, we're more and more surrounded by Fitbits and Nest thermostats and all these things. There's a lot of innovation going on that revolves around sensors that are affordable and internet connected. And why wouldn't we let young people participate in this innovation? The cost of sensors is falling. Just thus far, you still kind of have to be an engineer to actually implement it. And so, yeah, that's what I want to change. And so, yeah, the vision is that of a small device that you can connect a sensor to, and then you can program it on the internet. And so I'm just going to do that. There's a small sensor connected to my device. And I'm going to power it up because it doesn't have a battery built in. And it says connecting. Well, I'm pulling this up. And, oh, hey, we have some measurements. Can anyone guess what kind of sensor this is? Very good. Very good. Now we can think about how Fitbit works. Wow, that was interesting. How does that work? So this is the editor right now. So this is how I implemented that. There's the sensor, it goes to a chart. I did some math in between, which is also pretty simple. Oh, and I wrote this code simply by copying and pasting that. So I wrote this description, and it kind of breaks down coding in JavaScript super easy. Let's write, or I guess program this a little more. I'm going to say use a virtual button, and it's going to go to an audio out. And I'm going to connect these, deploy that. Of course, it doesn't know where it goes. It does.
Try me.
Ah. Now you can think of, I guess, coming up with all sorts of other words or even different languages for this. It's actually pretty fun to play with. And different other functionalities. You can send SMS, you can tweet. I made like a fake, or like, I don't know, a Twitter account for, so they don't have to create one or spam the one they have. Yeah, there's all these things. So that's pretty easy. Yeah, so, yeah, that's basically the thing I built. Again, you connect the sensor, and you can use any internet device, like an iPad or a phone. Many kids didn't bring a computer, so they use their phones to program something, and it comes in a box with a guide. Yeah, because many of you are engineers. I'm going to go into a little bit more of the detail of how this works under the hood. The sensor can either be a digital sensor, which connects over I2C, so just like 2 wires for digital connection and an address, or analog, so basically any analog sensor ever you can just throw on there, which makes prototyping super easy. Like I think about prototyping a totally different way now. And then whatever this thing measures, every quarter second sends to the cloud to a predefined MQTT channel. MQTT being a wireless protocol. I like to think of it as kind of like walkie-talkies for digital, where you just, instead of a frequency, you just have like a channel name, and then you can send whatever string on it, and everyone who accesses it can take it, can talk to it. So that runs on this classroom cloud server that sits in building 37. And the server, besides hosting the MQTT server, also has this programming interface that you saw. That's a Node.js application. It runs that on Docker so that I can have 30 of them for the entire class, and every kid can have their own. And yeah, so that's how it works. And you can also send strings back via MQTT to, for example, display, because the thing has a display, so you can like display messages or like stuff that you might have calculated in your program, and so it's kind of like you can build your own watch or Apple Watch, whatever. Yeah. So, hypothesis. This toolkit may increase the self-efficacy and interest in engineering in the girls that play with it. Self-efficacy being the confidence someone has in their skills. It's part of motivation. It's a very important indicator of whether someone is going to go into a career later on or not. And the other hypothesis being girls find it fun and motivating. The research contributions that I hope to get out of this are I'm building an activity, it's a toolkit and a curriculum. I developed measurement techniques to judge the impact of an educational intervention. I derived design principles for just STEM activities in general. Create a sharing website so kids can collaborate and all that. And from just a systems design standpoint in general, I adapt research methods for design prototyping and build an IoT prototyping tool. So the rough project outline is that first I developed an experience where I just not really going into the technology, but focusing on the actual experience. From that, can make a best guess about what it should work both from a hardware and software perspective. Build curricula, which are basically the experimental protocol, and assessment techniques for this intervention, and get results from those. And also build a web platform for sharing and derive design principles for similar such activities. Let's start with the experience. It consists of two different studies. One is kind of diving deep down into the psychology, focus groups, interviews. As per usual, when working with people, you start with just many questions. And the second one is to just reach a much bigger audience. And so let's start with the focus groups. There were 5 focus groups and interviews. I used very simple prototyping methods in order to make it more agile. So I used Google Slides to kind of fake an app that would run on an iPad or be displayed on an iPad, and modeling clay to make devices or device-looking things, so I could sit down with girls and say, imagine this does this and that does that. And the way that these focus groups were structured is that I had 2 hours with them, and first I asked them about their self-perception and problems they see in their lives, how they like their science classes, and then I showed them the prototypes, and I explained them, imagine here is an app where you can set these settings, and that has something that measures something. And the interesting thing was that their self-perception often changed between the first and the second part of the interview. And that's great, because that's called a mindset change. And especially those girls that first said that they're not creative, and that they're not technical, they don't come up with things. Those were the girls that had the most amazing ideas once I explained to them how this works. And the way that I can only explain this to myself is that once you've given them the mental tools to think about, perspectives as actual ideas, or then all of a sudden they manifest in that way. And that's great, because you totally change the way they think, and in a way you created an innovator. So that was a very great indicator. The other thing that changed was engineering perception. There were those girls, I asked them, what do you think of engineering? And or what do engineers do? And they were like, do engineers build bridges? Is that what they do? And I'm like, no. And then I showed them the prototypes, and one of the girls was like, I didn't prompt her, she just came back to that and she was like, wait, is this engineering? That is so cool. Also, the focus groups were very useful to learn about aesthetic requirements and relatedness aspects, and just to get the requirements in more detail. The second study was to reach a much bigger audience. The MIT Museum offered me to have a booth, and because I didn't have working prototypes at the time, I offered an activity that was to imitate the experience and the activity and to test whether it's engaging. And I used cardboard and stickers instead of an app with a drag and drop experience. And so young people were invited to create something. These are just two. But yeah, there were many different ideas. Also, at one point you will see, I'll get back to that. Some of them, I guess deviated in that they used multiple inputs or multiple outputs. That was something that also informed the design of the final implementation. But yeah, what was great to see is that it was actually really, really engaging. In spite of being a pen and paper activity, those girls were just like into it. They were serious about their. One girl, the one with the pink shirt, she made like a diabetes measurement, like blood sugar measurement ring, and or she made something to detect stress, and that will play music if you're stressed. And they were like very, very thorough, and took it very seriously. And so that was a great indicator for the activity being engaging. Also, it was good for deriving who designs what and with what tools. So I could derive that, you could say that's trivial, but younger girls like to play more with music, picture, action sports, and older girls actually also think about stress and safety and privacy, and the different sensors they use, and the different things they think about. Everyone kind of thinks about the weather a little bit. And to put that back on our relevancy map, you can kind of see that young girls are here where Scratch also was, whereas older girls were more into the altruistic medical regime, which is not surprising, obviously, but it's just interesting to think about it in this way. So now that we have the experience, let's go to the main part of this thesis, which you can also see as kind of like a third study that just goes much broader, much deeper. And the prototypes, you already saw the current version of the toolkit. But it's come a long way with, first just being, wires and PCBs. And the main things that happened between the second and third iteration were the addition of a display and some improvements in the code and other things. So now we've seen the device. Let's talk about the experimental protocol, which is kind of the curriculum. And the way that I structured those workshops was that at first I got them all on the same page about different smart devices, so they don't all look the same thing. And think about different options that they have for building things. Like you could, doesn't have to be a Fitbit. There's Nest thermostat. You can think about all other things that you might already know from your, also creating another relevancy there from daily life. What do you have? What do you know? And then I explained to them with a quick example how the programming interface works, and then they were given the chance to replicate that. Also, so that they kind of get a grip on it, and they don't have unrealistic expectations that have to be crushed later on. You can't build a rocket. And then we would brainstorm. Occasionally, it was just the instructor brainstorming, but you want to give them multiple ideas about stuff that they can build or at least think about. And then the main part was just actually the building activity with a short break in between. And in the end, there were presentations and reflection, and so more of the social aspect, which they very much enjoyed. And the different things that they made ranged from all over, I kind of say our relevancy space, where one of my personal examples is this lacrosse throwing meter thing that measures how well you've thrown and whether it was better than the last time. But there were also just funny things like this is the French-speaking pedometer, because apparently if you have a number and you set it to a French voice, it speaks French. And, or just things that were merely communication devices, like just sending text messages to someone's mom with compliments. So they were all over the place, and they were really good ideas. And yeah, okay, so that was fun. We have a hypothesis to test. How do you test a hypothesis? Questionnaires and numbers. So the questionnaires that I built and then refined later on had first just like a what is your general STEM experience question, and then I had a variety of self-efficacy questions, because that is kind of the most important parameter that I really want to get at, whether that self-efficacy and especially having social impact with engineering has changed significantly. Interest questions, like can you see yourself as an engineer later on? And then so these were both recorded before and after, so I could compare. Many girls were like, why do you have to answer these again? Sure, it didn't change. And I'm like, just do it. And sure, it did change. And the motivation engagement questions on a 7-point scale, again, 7 points is like from, I don't agree to I fully agree. And those questions were actually first drafted by the same people that also defined those, the gold standard for motivation, intrinsic motivation. I just adapted them. And then there were a bunch of open questions like, what did you like? And why? And what else, are your thoughts? And so this is what a self-efficacy question looks like. Usually they ask, how confident are you about your ability? But confident and ability are not really words that every 11-year-old knows. So how sure are you that you can do the following things? And then it says like, I don't know, come up with ideas for useful technical things, and so forth. On an 11-point scale, because according to Bandura, a teenager can totally handle that, and I agree with that. And the open questions, where they could just write their answers. And the results were very interesting. This is from a workshop last fall. The engagement of the activity was not quite where it is now, but the group then was so diverse that that was one finding that I could derive that I found really, really interesting, which is, so these are different girls that have very different backgrounds in STEM, from like I have never done anything that has anything to do with STEM to, I do first robotics every week. And you would think that maybe for some this exposure to this toolkit works better than for others. But no, they all have a huge increase in their self-efficacy in creating technology that has an impact on people's lives. And that's awesome, because that means that even if, at your school you offer first robotics or, I don't know, girls who code, still this experience can add to that. Oh, yeah. So, yeah, it's still significant over other outreach that might be there. Now you might see these and might be wondering, now is any of this significant in this group? And for that, because I have such small groups, statistics is not easy, because most of statistics to get statistical significance kind of relies on having very big sets of data, so the math actually works. For this small data sets, there's something called the bootstrap method, which basically means that you just resample. You take your sample and then you pick randomly with putting back, randomly from that sample, and then you do that, say, 10,000 times, and then you get something that is much more evenly distributed. Here, that is for the mean, so you pick randomly 10,000 times and get the mean, and then you put it on a graph, and that's what that looks like. And so it allows you to do statistics on very small numbers. What it does not do, point of caution, what it does not do is make your sample any more representative of the bigger population. So I can say whether something is statistically significant for the 8 girls here that I worked with, but I can't say that it works for the broader population. But yeah, and it's a relatively compared to many other statistical methods, recent technique, but it has been shown to work with, say, differences of paired data and to get the null hypotheses of that. So yeah, the graph you just saw here is the confidence interval, 90%. So that means that with a 95% chance, the mean of that have a social impact with technology that we saw the blue graph of. With a 95% chance, it is somewhere between like 0.2 and 2.8 or something. So that's what that means. So it's a pretty big chance. So that's why you can say it is statistically significant. Because 0 is not on that range, meaning you can reject the null hypothesis. So yeah, that's what that means. So it's a statistically significant increase for this group that we work with. Now that's the graph from last fall. Not all of these are significantly increasing. Some are, like we come up with useful product ideas because that wasn't reliant on the technology working. But like realizing a product, not so much. Also, there are still many different questions because I hadn't narrowed down the questionnaire yet. But if you look at the more recent graphs, there are fewer questions, and all of them have a statistically significant increase, which is very satisfying. You might ask, why math? Did you even do any math? I did not. And what I originally wanted to show is that the increase in interest in, say, an engineering career is not correlated with math so much as it is correlated with an increase in creative self-efficacy. Because a lot of education, there's still this notion that in order to get a kid interested in an engineering or tech career, you have to work with math and increase their math self-efficacy. Because that's also how they first tested how self-efficacy works. And I kind of wanted to show that it's really creativity that can impact their technical interest and the social impact aspect. Now it's still increased. I mean, some of the kids chose to make something like, I don't know, a thermometer or, like the lacrosse throwing. There was some math in there as well. It's not bad that it increased. I just couldn't show the thing I wanted to show. Making hardware with technology, I mean, I expected that increase. It did increase. That's good. The creating a product that people would like and use, it has a little more variation than I initially expected. The reason for that probably being that it says that people would like and use, but they never really got to go out and test it with people before they had to answer that. So that's probably why. And they make a difference in people's lives with technical solutions I come up with. That is the one I care about. I'm glad it's positive. And interestingly, that is the one that we saw this data off. So just to point that out, that something is statistically significant just means that it is pretty sure that the average is positive. It does not mean that every single data point is positive. Interest increase. What I find very interesting is that I consider being an engineer later increases so much. So that is what I wanted to see, and I'm very glad that that increased with this activity. Now let's go back to these motivational goals that we had, and going through the qualitative answers, I could find ways to verify or confirm whether I hit those goals or not. So let's start with relatedness. Could they make something that they care about? And it would appear so. I mean, answers like, I enjoyed it because I made something useful, just feels really good. Or different ways to help people around you. So that also implies that you can have different ways of implementing that in a meaningful way. Autonomy, that they are free to do certain things in their own way. I found a lot of evidence there. They definitely enjoy being creative and being able to make something their own. The continuous engagement, I had data, I didn't show that, but they're very engaged through the workshop. They perceive themselves as engaged. Perceived competency, that is mostly the self-efficacy measures that are showed, but also I found evidence in the qualitative answers. The collaboration part, I didn't find as much. Many girls didn't choose to work in teams, some did, which might have to do with the fact that most of the girls didn't know each other before they came in and we didn't really have time to do a bonding activity or something. And the meaningful objects, actually, they really, really enjoyed making something physical, so it really seems to add a lot over other things with this, being able to make something of their own that they can keep. Another interesting finding, so I talked to a variety of educators across the country, and it seems that, especially in the Boston area, schools don't necessarily offer STEM education as part of the core curriculum. So you kind of rely on students going out there and doing extracurriculars in order to get this exposure. And so I was very glad to find that kids or girls seem to actually really be drawn by this workshop. One family planned a US vacation accordingly because the girl was so excited about this. So that's good news. And I mean, in a way, it's sad that tech education isn't part of the core curriculum, but I mean, there's also a lot of after-school things out there in Boston. There was an interesting observation that I want to throw out there for future work. And so for the Cambridge Science Festival workshop this year, because there was such a long wait list, I divided the workshop into 2 different groups with different sets of instructors. And what I saw is that one did better than the other in a way, in terms of their self-efficacy increase, at least. And I first saw that something was different when I looked at the qualitative answers. The girls in that other group, which I'd like to call Group B, they still had fun. They still found it very, very engaging. But looking at some of their answers, the focus was just a little different. Like, they don't talk about, what did they make in terms of what was it for, but more what kind of technical components did it have. And then instead of talking about how much fun it was, it's more like it was very educational. And so I asked those instructors, well, how was that? How was that group? And they're like, yeah, kind of deviated. And both sets of instructors deviated a little bit from the core curriculum, but just in different ways. And I mean, on the first side, the main difference between the 2 instructors was their gender. I don't want to generalize anything. I mean, from a single experiment, there's no way we can generalize. I need to point out, though, that I cannot deny the fact that literature agrees that in middle school, a female instructor is better for girls than a male instructor. Not in college. In college is independent, but in middle school, that still matters. However, it is also true that if there's a very well thought through pedagogical experience, holistic experience, you can still overcome that. Like if there's an instructor that just really touches the right points, then a male instructor can work over the girl. And so I want to offer the hypothesis that this toolkit might be able to achieve just that. Just throwing that out there. There's no way I could test that with the little data that I have, but I ran a quick focus group with just 2 girls, so no statistical anything, but just to see, test the waters. And after giving very, very detailed instructions for emphasizing social impact and personalization and everything, the 2 girls, and here's their self-efficacy increase respectively, it is comparable. I mean, there's nothing statistical that we can actually derive from this, but it's just the first step, and maybe kind of to lay the groundwork for an investigation that might happen. So let's talk some more about the device, because those experiments showed a lot of interesting things that impacted the device design where it is now. First off, the display. Many girls said that they really wanted a display also to help them understand what's going on. We already knew from the motivational criteria that the continuous engagement and autonomy, perceived competency, always knowing what's going on is important. It was just from those theoretical criteria not very clear how that will be implemented in such a toolkit. And so we had to find this out in this empirical fashion that it just needs to have a display, and a light is not enough, and It actually needs to have a display in order to fulfill these criteria. Another thing, many kids wanted guidance, and that is, for example, how this booklet came to be. That kind of tells them what to do next if they're ever bored or don't know what to do next, and also there's kind of like a help explanation for everything in the program, so you can always click on that. A story I've heard about how students like to be guided is that they kind of want to have this big book that's always available, but they never have to use. And so in a way, that is that in a digital fashion. Many girls also pointed out that they really wanted to make it a wearable, and so one step in the right direction is done by, you can kind of make it a wearable. It still doesn't have the battery inside, so it's part of the way there. It is not perfect, but at least it's not determined what would the right way be. Also, you might ask which sensors does it have right now. You can use an accelerometer, a temperature sensor, or a heart rate sensor, because most girls were most interested in these. Very, very few girls asked for GPS. And light sensors or pressure sensors are not really asked for. It would be interesting in the future to just provide them and see what happens. But yeah. And on top of the list of what would you like to measure is emotion. I guess 13-year-olds. And so far, they mostly use temperature sensors or heart rate sensors for that. The programming interface is an adaptation of IBM's Node-RED, and Node-RED is a tool. It looks a lot like this, but it was made by computer scientists for computer scientists. So the whole language of the interface was totally changed, and I had the help of dedicated high schoolers to do that. Also, Node-RED is, in a way, you can put it on your Raspberry Pi, but only one user can use it at a time. So I implemented that on a server in this multi-instance management system so that everyone can use it from everywhere. I learned, for example, that girls really need to have it be kind of real-time-ish and be able to, yeah, like the 10-year-old, if you I was at the MIT Museum for a booth, and there was, I think, probably 10, 11-year-olds, and when I mentioned something about 3 axes, she just walked away. She just didn't, just turned away and just walked away. And so since then, the accelerometer just streams a single point. It's just the amplitude. That's all you need to know. Yeah, so it came a long way. So now that we have that, we can derive design principles that might be applicable to other educational and STEM educational activities. I'm only going to list those that I found here. There's a rich body of literature out there for just like good learning experiences in general. But what I learned here is that yes, real world social impact is really, really important for girls, and that it often it's something that you just have to pay attention to, especially instructors. You get carried away and you just have to focus on that. And physical objects make things much more meaningful. And another interesting thing was that if there's any sort of variation in an educational technology that you use, and there's a lot of technology in education now, if there's any variation, it has to be clear whether that is intended or not, and whether the student can influence it. Because you don't want to be in a situation where the student tries to fix it, but they just can't. So that's very important. And then, yeah, autonomy, collaboration, etc. But these are kind of, people already know about those. So we had great results in terms of self-efficacy increase, but it's known that that might just be a temporary effect. And so the question is, how can we keep engaged, and how can we keep it going? And that brings us to the website. And I implemented a website where students can share projects. They can also just share the entire code, part of the code, just some pictures, explain it in any way they see fit, post videos, etc. They can comment on each other's creations. They can download what someone else has. Another interesting feature that, say, platforms of the Little Bit or Scratch that I got good inspiration from don't have is that you can collaborate on a project, can have multiple creators at once. And I implemented that using just a Joomla open source CMS with a social network component that I heavily altered. And so that's what it looks like right now. I invite you to go there and try your projects, except it doesn't have any users really besides me. But maybe in the future. So yeah, so that is the project with all of its parts. And yeah, let's talk about the future. I'm going to keep doing this and hopefully pilot at some schools. I'm also going to launch kind of an after-school competition similar to First Robotics, but more product design focused and social impact focused. Because I heard from the people who run First that there's just no free capacity to change their focus in any way to account for girls' needs. Also ramping up the website, improving the design of the device further, yeah, and of the interface, and hopefully reaching many more other minority groups with that. Here's a quick sneak peek to the curriculum I'm developing. I hope to publish that soon on teachengineering.org. And we're engineers. There's always more to improve about any technology. So yeah, it's not expensive the way it's fabricated, but 3D printing these cases obviously takes a lot of time. Yeah, so there are many things you can still improve. The interface right now, in theory, everyone can log into everyone else's interface and change whatever they want about it. So there's some room for improvement. Yeah. Another thing to just put this in a bigger context is that you see all these different movements. You have more maker spaces, you have 3D printing, you have Fusion 360 making CAD available to 13-year-olds. And so that's all part of this, as I've heard, democratization of engineering and putting engineering and the ability to make things, make hardware into the hands of everyone. And I think that is very empowering. And in a way, I feel like this toolkit product can be part of this movement as kind of an easy-to-create IoT ecosystem and fit with that and help empower all sorts of groups that are not currently part of innovation to innovate and contribute their ideas. Yeah, I mean, in a way, we're using more and more technology, and we want to be actively shaping it. And I mean, even already students are encouraged to 3D print their own cases. Many schools have maker spaces these days with 3D printers. And so it's nice that it all goes together, and that makes it in turn more motivating for the students as well. My research contributions, I built this toolkit with a curriculum, with the activity, develop measurement techniques to assess the impact of an educational intervention. I derived STEM design principles, built a sharing website, even though it doesn't have a very used yet. And I have a measured impact on 49 girls that had a significant increase in their self-efficacy and reached many, many, many more girls in the process. And I, in the broader systems engineering perspective, adapted those research methods for systems design in an agile fashion and developed a rapid prototyping platform for IoT. Publications, there are some process. I definitely want to reach the broad mass of just educators and parents with this because I think it's important. I'm very, very grateful for all the educational institutions that help me run experiments, run workshops, get girls together, and get good data. And I thank everyone. I thank all of you for coming and for helping me along the way. And most of you have been extremely helpful. And Oh, hi. Yeah, and I'm so lucky. I could not have done this without anyone on this list or any of you, especially being a machine designer entering the working with people space. I'm very, very grateful. Thank you so much. All right. Yeah, I think do we want to do professors asking questions first, or everyone?
Good.
I think open.
Yep.
Yeah,
Open. Okay. All right.
but I'll start.
Yes.
You know, like just slide 36. Yeah, so I was surprised that create technology that has an impact on people's lives has a significant change, but have a positive impact on people's lives does not. Do you know do you know what the difference is between those two questions?
Yes. So the second question is just a general, right? Have a positive impact on people's lives.
Yeah.
And there's, I mean, technology. Yes, they use technology in the workshop. They, you know. But just having a positive impact on people's lives. For one, it's a super general question, so it's always prone to error with self-efficacy questions. So that was kind of poorly worded in the first place. But then also because it didn't really address any of the things in the workshop, it's, you know, looking at it now, obvious that it didn't increase. Yeah. Yes.
I have a rough idea. To reach like a broader audience, you have a BOM of $20. Do you have a rough idea of where that price should be to reach every single school in Boston?
I heard from one educator that some schools have a budget for the tech class of $100 for the entire year, for the entire class. Using hardware, that's obviously pretty challenging. One idea that I had was basically to just use the circuit board that's in there. I'm just gonna put the part. Nope. Use the circuit board that's in there. That's maybe $4 and. Just this without the display, even though I know the display makes it much better, but it's a cost, you know. Yeah. So.
Can you get a tech company to just give you the parts?
That would be nice. Yeah. If someone else pays, you can reach a lot more people. Yeah. It's a great idea.
Can I ask a question?
Yes, please, Eric.
So actually, I have two questions. So the first one is, we've talked a little about this. You know, there's that difference between the instructors at the Cambridge Science Festival. So clearly, whether it's gender or not, clearly instructors make a difference.
Yes.
What do you think? You know, if you're trying to do some sort of scaling of this, what do you think would be required for professional development of people trying to run this activity so that they can do it as effectively as possible?
I mean, what I did in the instruction ahead of the workshop was just to say it's very important to you know, if they get ahead of themselves, ask them what are they going to use it for, who is going to use this, and be encouraging about that. And I think maybe scaling it up, you say, what might be helpful too is to have some other mechanism in the toolkit that even if the instructor doesn't really emphasize it, or even if they explore this all on their own, they're encouraged. I mean, this could be part of the guidebook website ecosystem where if they explore this all on their own, they always get encouraged to think about these things. It could also be, there could be some affordances on the website for how you share it. That there could be like an extra, box for who did you think of when you designed this, to encourage that. Another thing to even more independent of instructors and for scaling up is that my plan is to run kind of monthly challenges on the website that are like, meet Max. Max has autism. Here are his problems. Let's design something for him.
Good. My second question is sort of a controversial one. When you're thinking about something like this, you could market it as this is a STEM toolkit for girls, or you could market it as a STEM toolkit that girls might happen to like.
Yeah. Yeah.
And how do you think about that difference?
Especially with Generation Z, who are gonna have to use it. They're pretty allergic to like, this is for girls. Super allergic. And there are products out there that are clearly made for girls, but it doesn't say for girls anywhere. It says for everyone. Like these bracelets with like, different pearls. They're for everyone. It's just how this generation works. And so very clearly, it can be as openly designed for girls, but you can't say it.
Yeah. Even easy bake ovens now are actually being non-gender branded in their form. In fact, they found that there were lots of boys that wanted them as kids but didn't get them because they thought they were for girls only.
Yeah. And I think the reason for that is twofold. In part, because with social media, they grow up, they don't want to be marketed to. There was one girl in one of my workshops, and Google sponsored something for them, and they felt like they're just abusing them for marketing purposes. And the other thing is that they do grow up with more fluid gender ideas. So like, they just don't grow up with like the same categories that maybe we or older generations had. Oh, these are many questions. Who's first?
Yeah. So the workshops that you ran, did the girls took their devices home?
Whenever I could afford it.
And did you have any mechanism to see whether or not they're continuing to use it? Can you see server activity or anything like that?
I can. I didn't check, but there was. I think it's something that kind of tapers off. I got some emails like the day after the workshop, like how do I do this again, and what is the website again. But until like 2 weeks away from the workshop, you don't get any emails anymore. So. Yeah, the keeping engaged part is a tricky one, and for that, I think the ramping up the website part is the first challenge.
I had two questions about your framework where you have the overlapping areas in. Could you pull it up?
This one here?
Yeah. So first of all, I really liked, somewhat related to what Mark asked, I liked how you were able to map where some of the younger kids are towards the scratch area, and then as they become more socially aware and conscientious of how they're doing affects more people and the communities, they move up, they move around. And so do you have a sense of how long their interests stay there and how long they're interested in engaging this sort of IoT platform as an outlet for that? Or is it just too early to?
I think it's too early to tell. My hope would be that they just stay engaged with that in their adult life.
Yeah. And the other thing is, so for the sort of, I guess the greenish blue medical sports health, that seems to me to embody the sort of like creating specific devices and how did you, right, there's also no, right, you obviously don't see bridges and infrastructure in there. Does that come out of just the results of your surveys, or did you kind of impose that? Where's that distinction? Why is there no like big industrial hardware in the framework?
To create the space, I went from kind of the career ideas that they have.
Okay.
building bridges isn't really in there.
Yeah.
And from the interviews that I conducted, they just didn't seem
No,
very
it
interested in
it doesn't come up at
civil.
all. Okay.
Yeah. It's just that. And I mean, yeah, and you can also argue that, you know, engineering is so much more than just electrical engineering or device design. You know, you have all of fluids and other things, which is not covered by this. Yeah.
Just this is I think supporting what you're saying. You got to remember this is for 12-year-olds,
Absolutely.
and it's planting the seed. And actually, your math self-efficacy.
Mhm.
The fact that it went up, at least for me, was not overly surprising, even though they weren't doing math, because I mean, at the root of this is motivation,
Right.
right? An educational experience that motivate, and in some sense, by motivating to want to do something, that will increase someone's belief that they could do something they're going to need to do the thing they want to do.
Yeah.
It's also thinking like an engineer,
Oh yeah,
right?
absolutely. And I mean, there's a lot of opportunity once they become more aware of the world of engineering to move around. I was just curious. So this came just straight out of the answers that you were seeing in the survey populations. Okay.
Yeah, I also in the first interviews I also made maps. Of anyhow, of with the Europe's that helped me with those studies to kind of map their interests, kind of like the ideal way where you just talk to people about their lives and then you write down the needs that they have and then you categorize them somehow and then you find like the categories of needs. I think Maha first and then Nick.
So thinking about the technology itself and the IoT stuff, were there any challenges or do you foresee that any improvements in that technology space could lead to your toolkit meeting its goals a little bit better?
Challenges specific to
Like to IoT and where that technology industry is right now versus like where it might be going. Would that help your device meet its goals or what is it pretty good enough already?
I think it will definitely be cool to integrate more different sensors, like where there's a lot happening is say sensing gases and smells and things like that, and that would be interesting, or just different other environmental things that you could sense, and it will be cool to integrate it with, just make it in a way so you can integrate it with many other aspects of life. Tinker and build. So I think it already works for girls, but yes, it could always be better and meet more of their interests. And I'm looking forward to incorporating whatever comes along.
I guess I was looking at the project and seeing that it seemed like another thing that made things relevant to teen girls was also things they encounter every day, like their sister, their mother, prostitute, right? And in particular, the introduction of the sports category into the medical category, which I think makes a good deal of sense. But it seems like this map is a lot about future ambitions, and a lot of the ambitions that are represented in the design challenges seem to be more kind of local, more kind of the creative capacity building thing of like seeing your life, seeing challenges in your life as design problems.
Yeah.
And I guess, I guess I was wondering how that, I don't know, like either the temporality of ambition or just like whether people are making, whether the students are making things for themselves and fantasizing about that, or whether they're like fantasizing about like a career and trying to make something that like the entire sports team could use. Wait, it's sort of there's a breakdown between social and individual, but also
Yes.
kind of between what's relevant to you now and what you want to be relevant to in the future.
Yes. I think, many of the girls came up with things that they wanted to make for others, like for their mom, for their sports team. Interestingly, I saw in focus groups that kind of like, if the device looks nice, they want to make it for themselves.
So like, in both directions. Like,
Yeah.
Something that looks nice, you're like,
Yeah.
oh, that's probably for you.
And in a way, it's also having, say, a piece of jewelry that looks nice. That has social, effects as well.
Oh, for sure.
Just not in the altruistic way necessarily.
I was going to ask, you talked only about girls here, and then you bring out some of the kind of marketing to girls versus for everyone. Have you done any studies with boys, or I guess in general, you move forward? Would you try to reach both genders?
Yes, I ran a workshop with the Science Club at Buckingham Broaden, which was 2 girls, 11 boys. And over the course of multiple weeks, I also found different ways to address the boys' needs, especially boys at 4 p.m. after a day of school. They get to be kind of, you know, full of energy. And so that is when I, for example, made like this thing that kind of the build your own high striker challenge. So they would attach an accelerometer to this, and you know how high striker is like this thing, you hammer it and then it goes way up, and the more you hit it, the better, or whatever. And so they could build a digital version of that, with all of the excess energy that they had. Also, they were more numbers driven. I guess it's something that First Robotics really gets at. You know, am I winning? Do I have the Heisman? How do I know? You know, but boys seem to focus a little more on that. I didn't prioritize it, but I found different ways to do that. Yes.
So where would a career such as like an astronomer or a biologist fit in this framework here? Scientist in general.
It might be a different category.
Would you
and
consider
sort of
adding like a science or
Yeah.
understanding?
Yeah, I guess the reason that it's not on there is that it's just not really in the statistics of what girls want to do when they grow up. Yet? Okay, yet?
This is what you
Yeah.
Okay.
Oh yeah.
I was curious about the girls that you interviewed or used for your polls and your studies. Were they primarily in like city or metropolitan areas, or did you interview any who were from rural areas, from more rural areas?
Most of the girls were in the greater Boston area. I also had a round of preliminary interviews in rural Indiana a few years ago. And it was interesting, yeah, there were minor differences, but the differences between like how a middle schooler and a high schooler thinks were much bigger than between how does someone from rural Indiana think versus someone from Boston. Was that your question, or do you have more questions?
Oh, it was sort of me trying to dance my way to Aaron's question about it. Because I'm wondering also if, like, some of these people are people that people from metropolitan areas encounter a lot. So I was wondering how much it was just lack of exposure to a biologist.
Yeah. And these like career ideas, they're from a study that asked, I think, 3,000, some 4-digit number of girls about their career aspirations. I think the lack of exposure is oftentimes what is the problem with any like the lack of exposure to engineering, which is kind of at the core of girls not being engineers.
But not to engineering, but like people who are engineers.
Like the role model.
Yes.
Idea, yes. The influence of role models is also something that is debated much in the STEM field. And it is said in general, you have to expose girls to women engineers so they think about engineering. I think that is probably true. I think that it is even more powerful though, or especially given that there are just not women engineers everywhere, unfortunately, that to give them the opportunity to experience themselves as engineers. But talking to women engineers whenever it is possible definitely helps to even just make sense of their budding engineering interest with budding like what kind of woman do I want to become, and make sense of that. Because often, especially with us in Western nations, where there's a strong cultural notion of what is a woman, it's sometimes just difficult for many girls to make sense of that. And so, yeah.
one final question.
Just curious, did you revisit afterwards any of your subjects to see if where they map themselves on this possible chart?
I did not.
Or did they start to add engineering or scientific fields to their possible career?
I didn't ask about possible careers. I just had this one question. I could see myself as an engineer one day. That went up significantly. But I didn't look at other career ideas that might have changed as a result of that. But it might be an interesting point to look at. Thank you.
That's all. Thanks, Larissa.